Hi guys, welcome, good evening all. This is Ashank David and welcome to our Saturday weekend live session where I am gonna tell you about DSA, data structures and algorithms, which is asked in placements, and I will be discussing today about from where we left in the last class, in the last live session. We were on linked list concept, so we will continue from that concept. And if you remember, in our last live session we were on linked list, where I was teaching you about linked list and I was teaching you about linked list functions. So we have just finished creating our node and we were about to start with the insert functions. So in insert functions I told there are three things. Actually there are three things which I have told before, that is insert and delete and traverse. So we are going to talk about all of that in today's live session, but I will tell you about this, that first how insertion can be done. Okay, let us talk about that here. So let us start now. So in the last live session we were on to linked list concept, and in that linked list concept I have finished up till linked list introduction and finishing up the node creation. So in that class I have just finished up with node creation. Let us continue from there and let's start. So just for the quick revision, let me just revise what we have done in the last class. Here I have created a linked list. I have told that in the previous live session just a minute guys, this was our linked list where all of these are nodes and each node will have its own address and there is some head connected. Okay, there is some head connected. This head is always going to point towards the first index. So let us say this is 2187, so this is 2187. This is 2819, this is 2919, and this is 2312. This was the next, and here was the data that we have placed. So let's say data is 10, 20, 30, then we have 40 here, and let us say this is going to hold 2819, so that it is connected to this. This is going to hold 2919 and this is going to hold 2313. We have 2312 and this is going to be null because this is the last node. So we have understood about this. Let us see from where we left. So we left on the concept of creating the function for the next function for the linked list concept, and that was the insertion function. So let's start with that. So in the last class I have told how to start initializing by creating the node first in the linked list, because if you want to create a linked list then you would have to create a node first, and to create a node first you need to create a class called as node. Okay, and in this node class we have taken, in the public section of this class, we have taken the int data to represent that node, int data, and node star, if you remember, node star the next pointer which is pointing towards the whole node itself. This was the thing that we have discussed, and just this class we have finished. This particular class we have finished last time. Now let us continue from here, and the next thing is I have told that here we would create the insertion function. So guys, three things I have told, and that is functions. If we talk about the other functions, if I want to do anything, if I want to create any of these nodes. I have done creating the class, but next thing is what I need to do is write some functions to do some operations, okay. And what operations? 3 operations I have told in the last class. One is insert operation, another one is delete operation, and the last one which I have told is traverse operation, okay. These 3 things. But to reach delete and traverse, it will take some time. Traverse we may do it in this class only, but insertion we will have to do here first. So let's start guys, and let's do the first function, that is the insertion function. Now before I go ahead into the logic, I wanted to finish up the program which we left last time. So in this class, let us finish up that first and let's start. So here in the main function, we will write our main function later on. Let's start by creating the class. So I said class node, and here I said in the public of this node class, I would say int data and node star next, okay. So after doing this, what happens, our node class is ready, our blueprint for node is ready. Now what we will do, we will start by creating a function. Now guys, here the thing starts. This much program we have already written in the previous class. Let us start by writing the functions. Now here I have told something, that in this blueprint is ready for creating the node. The blueprint is ready. The next thing what we need to do is, we need to write some functions so that those functions can be called inside the main. And if you are able to call those functions inside the main, you can do some operation on this linked list. Right now we are not doing any operation, but we want to do some operation, and that operation could be our first operation, insert operation. So if I run this program, nothing will happen because there is no linked list only created. We have to start by creating the linked list, and if I want to start by creating the linked list, I need to insert the element. If I want to insert the element, I need to create a node first. Our blueprint is ready, so I can create the node, I can insert the node, and I can start creating the linked list. And how will it happen? The very first function that I want to write is gonna be the insert function. So basically insert function I have to write. There will be some return type of this, but guys, I'll teach you one trick today. There you may find on other places or on in some other classes, there can be different methods. Everyone has different methods of solving a problem. It's straightforward, simple. Everyone has their own ways of solving the problems. Okay. Today I will show you 2 ways. Some people might think that is easy, or some people might think the other way is easy. If you want to understand the first way, you should know about call by value, call by reference, pointers thoroughly, and if you are doing the second way, then you need object oriented programming more thoroughly. What I am talking about, you see here in a moment. You see, first of all, understand the logic what I am trying to say. My next step in this linked list is to create a function for insertion, and the first function is the insert function. Okay, we are imagining right now that this linked list doesn't exist in the beginning. We are thinking that this linked list is not existing. So what I'll do, I'll start by creating a node and inserting the node. Where do I insert the node? There are 3 places that you can insert the node. There are 3 places where you can insert the node. The first place is gonna be insert at head here. Okay. The second place can be insert at tail right here. The third place can be insert in a specific position, for example right here. 3 places I can do the insertion. Imagine if the linked list doesn't exist, then where do you start the insertion from? Of course from the head, because you have only one reference point to start, and that is head. Before you create a linked list, before you even start the linked list, head pointer is initialized, and we have discussed this in our previous lives also. Head is a very crucial part of the linked list concept, and if head doesn't exist, the linked list doesn't exist. That means head is the starting index of a linked list. And if I want to start the linked list, I want to start it from the head. Are you getting my point? So, imagine if this linked list doesn't exist. If this linked list doesn't exist, then the head would be null. But head will be there, no? If head is null, that means there is no linked list. It's very simple, very simple. Okay? If head is null, then there is no linked list. If you are doing the insertion for the first time, where do? You will do insertion at head. Are you getting my point? So, in the beginning, we can imagine that the head is null, and if the head is null, you will create a node, and itself it will become the head. Are you getting my point? This is our first step, imagining the insertion is being done when the linked list doesn't exist. But what if the linked list is existing already? Imagine this was first scenario where I have told that in the first scenario you are imagining that the linked list doesn't exist. But let us say this time the head is not null. Head is not null. In that case, you can do insertion anywhere. If the head is not null, that means this linked list exists, and if this linked list exists, there are three things that you can do, either at the head or in the middle or in a particular position. I am not talking about middle. In this case, you can insert it anywhere in the position. Okay. So, basically there are three things that can be done here. If this linked list exists, then the insertion can happen on head in the any position and in the tail. This is also one scenario. Understood? But before I go there, let us talk about when the head is not null. Means if the head is not null, in that case you can do any of these three things, either insert at head or insert at position or insert at tail. Correct? In that case, what you will do? You will imagine a case where if the head is head is not null, in that case you will create a new node right here, store the data right here, let us say it is 50. Then you need to connect it here and then move this head here. Are you getting my point? So, guys, we saw two scenarios. We discussed just now two scenarios. One scenario when the linked list is empty, another scenario when the linked list is not empty. Understood my point, guys? Is that clear to everyone? If you have any doubts, you can ask me in the comment section. I am seeing the comment section right now. But I hope so that it is easy to understand, right? Okay. Yeah. So, now let us continue. Okay. Alright. So, two scenarios I have told about insertion. If I want to do insertion, you see in the insertion, two scenarios. Scenario number one, when the head is equals to null. That means the linked list doesn't exist. If head is not equals to null, there are two scenarios. Okay. So, for the better understanding, what we will do? We will do first when the head is not equals to null. Why I am saying this, you will get to know in a moment. because I am experienced in this, because that is why there is some reason behind it. When I'll start writing the code, you will understand this. So with the experience, time to time, you will understand and it will come. Okay. But let's continue. Let's just start here. The very first thing what we will do is imagining that the head is not null, means if the linked list is present. Because in this case, any of the places can be inserted. The newly created node can be inserted in any of the places. How to tackle the situation? We need to understand that first. So let's continue. Let's start. Let us start. And as I told you, if we are imagining, if let's say I'm going to write here only. Okay, let's do one thing. I'm going to write it here only. Imagine head is not equals to null, means the linked list is present. In this scenario, there can be three things can be done. Number one, insertion at the head also can be done. Insertion at position can also be done, and insertion at tail also can be done. This is scenario number one. Scenario number two says that the head is equals to null. That means this is true. In this scenario, there is only one possibility, and that possibility is you can only insert at head. You cannot do insert at position or insert at tail because the linked list doesn't exist. Are you getting my point? This is the thing. So, if the head is null, in that case you can just remember this. If the head is null, then only at head you can insert. If the head is not null, then you can do three things. Understood? Right. But we are taking the scenario of when the head is not equals to null. Why, you will get to know in a moment. Here head is not equals to null. That means the linked list do exist. That means this linked list exists. Guys, understood that this linked list exists. And if this linked list exists, insertion can be done anywhere. So I can write insert at tail, insert at position, insert at head also. Okay. But in the beginning, where do we start the insertion from? Insert at head. So let us do one thing. Let us do insert at head. Insert at head we will do. If I want to do insert at head will be a function now. I will write the function called as insert at head actually. So here in the program, I would actually say insert at head like this. I would say. And then I would write the rest of the code here. But guys, as I told you, I will tell you two different ways. There are two things that can be done here. Either you write this function, and what will be the return type of this function? It will be void. Okay. Void insert at head. This is the function name. Understood my point, guys? So this is your function name. This is the function signature. Now if I wanna, there are two things that you can do here. Two ways you can do. First thing, you can write this function outside the node class, just outside, just once the node class is over, just after that you can write in the global space or in the global scope directly like this, or you can write this inside the class by creating another class called as class SLL for singly linked list. I have said I have created a class called as singly linked list. Inside this singly linked list class, you can write this function. What I mean to say, Either you can write this function right outside any class, or you can write this function inside a class. So guys, two things we saw here, either outside the class or inside the class. What is the benefits and what are the perks? So guys, the perks or the benefits are nothing, it's very simple. Actually here, if you write the thing inside the class, if you write this function inside the class, what will happen? You don't have to write one extra variable. Let's say for example, I am going to actually tell you what happens when you don't have this class called as single linked list. See, first of all, you need to do insert at head, and in this scenario right now in this program, this is the class node, okay, this is the node class. If I want to create a node, I can just start by, see, if the linked list is there, and if I want to do first insert at head, I need to create the head first. So, I will start by creating the head, node star head equals to, I will initialize it to null. That means in the beginning the head is null. That means there is no linked list present. Clear? Is this clear, guys? So, head is null. But where I am creating this head? I am creating this head in the main. And when I create this head in the main, the function requires head. Because you see, if you are asking someone that you take the value, so first thing, what will be its parameter? A value that has to be inserted at the head, and the head's address. Are you getting my point? Two things, guys, two things. Number one, the value which needs to be inserted, and the head pointer reference. So, if in the main function, if I call this function insert at head, in that case two things I need to give. First is the value, let us say 10 I am inserting at the head. Next will be the head's reference, ampersand of head, ampersand of head. If I am writing ampersand of head, then I have to write here star star. Double pointer. Guys, remember the class of pointers? In the very first DSA live session, I have told and explained this. That session is also recorded and it is already published into our YouTube channel. So, if you have not seen that live session, please do see that live session. There I have explained you what are these double pointers. Or if you are not able to search it, then you can just search our pointer videos, where I have only explained you what is a double pointer. There is a separate video called as pointers in C. If you see that, you will be able to understand what is this. Okay. So, now let us continue. This is a double pointer, and you see that here I am passing the reference of the head. Why I am passing the reference of the head? I am doing call by reference. What is call by reference? Also, I have explained this in our previous live sessions, and video is dedicatedly there in our channel. So, if you don't know what is a call by value, call by reference, double pointers, there is a video. We have created videos on each and every concept that we are speaking right here on our channel, Coders Arcade. So, you go ahead and watch that. We cannot repeat everything again and again in every live session, right? So, this is the concept of call by reference. Why I applied call by reference? Because my head was inside the main scope and our insert at head is outside the main scope. Head is here, head is being initialized here, but we are needing that here because this function is going to go to the head and to the insertion, right? And if this guy does not know where is the address of or the location of head, then what will happen? It will not be able to do the insertion of the head. The insertion will never happen, and that is the reason why we need to do call by reference. Well, I hope so that you are able to understand. If you have any doubts, please ask me. Okay. No comments till now. So, I believe that no doubts. But let us continue. Okay, so now double pointers, insert at head function, absolutely sorted, everything is sorted, everything is understood till here. I have created head pointer here. This is one way of doing the program. Alright, this is one way of doing the program. Another way, I told you another way. Another way is to create a class called as singly linked list, and inside this class what do you do is what did we learn in the object oriented class? There will be two things, public and private. Because in this class node I did not want anything to be private, so I did not make anything private, but I wanted everything to be public, so I made everything public. But in this class I can make one thing private, and that is gonna be the head. Head can be initialized here only, node star head is equals to null, or I will not initialize it. Following the rules of object oriented programming carefully, I can create another public section. Public section, this was private section of the class, then now inside the public section of the class I can create the constructor. If you remember what is constructors, we have already covered this also in our object oriented classes. So please go ahead and watch that also. Everything is there. Creating the constructor, and inside this constructor, what did I do? I said I will initialize the head is equals to null. See right here. So what happened now here is that you don't have to create the head in the main. Now you can absolutely delete this line. Okay, and if you create that, you don't have to even pass the reference of the head because it is not needed now. That means you don't require this head also. Okay, but what is the situation here? You need this function to be written inside the class. This is the only condition, but in the public section of the class. I hope so that this is very much clear to all of you guys, right? Correct. So here we have the class node and we have class singly linked list, where in the private section of the class we were creating the head and we wrote the constructor. So this is easier way. Actually in this way you don't have to. So in this case what will happen is, now I have to create the object of singly linked list by saying SLL and then obj, or I'll say LL for linked list. This is the object which I have created, and I'll say one line here, that is LL dot, because in object oriented programming if any function is written inside a class, then that function has to be called by creating the class object first, which is this, and then using that object you need to call the function. Correct? Did you observe one thing, that here I did not pass the head because head was not created here, head is already created here in this class, so I don't have to worry about anything. Are you getting my point, guys? This becomes much more easier. This even becomes much more easier to understand, right? So this is the second way. I told you two ways now. First way is, without creating the SLL class or singly linked list class, you can directly write the insert at head function outside in the global scope, which will require you to create the head in the main. And if you create the head in the main, what you need to do? You need to call the function and pass the reference of the head, and hence you are doing call by reference. If you miss that part, then the linked list will not work. That becomes a little bit complex and difficult to understand at first. But if you want, you can create a class called class singly linked list, and here once only you can just create the head, initialize it, keep it like that, and then write the function here. Alright guys, so let us understand how this will work. Let's continue. Right. So I am gonna continue this way only, because we believe, most of us believe this way is far more easier. Okay. Alright. Okay. So yeah, so hello guys, in the comment section they are saying hello, good evening sir, hello everyone, nice. Yeah, so we are learning here linked list concept. Let's continue. Okay, so here we have this class, and here we have the function. Now let's continue writing the function. Okay, let's continue writing the function guys, come on, let's continue. So here we have void inserted head, and I hope so that this thing is very much clear to all of you that this is how it is done. Either you go with the first way while you are creating the function outside the class, or maybe inside the class. The differences I have already explained you, so we can continue according to it. Now we will go back here in the whiteboard and understand the concept of how this is gonna work when I am doing insert at head in two scenarios. I told you one more thing, two things here. When the linked list, when the head is null and when the head is not null, correct? If the head is not null, that means this linked list is present, and I told that we will follow that. Okay. Here what I need to do is, I'm imagining right now that this is our linked list, and here I need to, I'll just bring it here so it becomes easy for me to write as well. So now I'm thinking, I'm seeing that the linked list is present there, and I want to do insert at head. And if I want to do insert at head, what I'll do? First step, I'll create the node. Create the node. Node is created. I have stored the data. Imagine that this is of address 3120. 3120 is the address. Right now this head is pointing here, and that node is created. How do I create the node? Okay, we will talk about that later on. First step is to create the node. Create node. Okay. Then the second step. So first step is done. Created the node. Okay. One comment. I'll see that comment. One minute. You see, I have created the node, and after creating the node, what I'll do? I need to connect this. How do I connect it? If I want to do this connection, I want this address. How will I get this address? Who knows this address? Head knows this address. And if head knows this address, I can say, head, you give me that address. Am I correct? I can say, head, you give me this address, because head is pointing towards this address. So I will say, head, you give me this address here. Logical, correct? Am I correct? I believe so, it is logical. Right. So if I want this address, I will say, head, you give me, and I will store this. So what will happen? I can store this 2187, means this connection is made. This connection is made. First step is done. Second step is, I'll say, the second step is copy address from head. Copy address from head. Third, what is the third one? Head is pointing here. Head is pointing here. That means this is the first node right now. But my first node should be this. That means the head should point, head should not point here anymore, head should point here, and if the head should point there, that means this address will change to 3120. That means the third step becomes move or point head to the newly created node, which is imagining n. So these are the three things if you want to do insert at head for when the head is not null. Understood? Let us code. So till here I hope so that this is very much clear. Okay. Now one comment is there, how can I prepare, can you please zoom in, zoom, okay, how can I prepare for DSA for C++, I just know the very basics, okay, how can I prepare for DSA, how can I prepare for DSA for C++, I just know the very basics, okay, MRN SemPy, okay. So for this, if you know the basics, you can try solving problems on Coding Ninjas. So if you try to solve problems on Coding Ninjas is a platform. Now this live session is not paid, this is not paid promotion guys, or we are not sponsored. I am just telling you that you can, if you want, you can try on Coding Ninjas. Coding Ninjas is a platform where you can actually go and practice the questions. If you practice your questions, if you are okay with your basics, and if you are feeling confident that I can start solving the problems, you can go ahead and start solving the Coding Ninjas platform problems. And if you solve there, your profile will become strong, and when your profile becomes strong, automatically your hirers or multiple companies will start calling you based off of your profile. And if your profile is good, you can get a job easily. The best way to practice is you go to Coding Ninjas and then do practice, okay, MRN. Other thing is Lead Code. I would suggest Lead Code also, okay. Lead Code and Coding Ninjas, these two platforms are one of the best platforms to start studying, if you know the very basics. Then what do you think about Rust programming language? Is it widely used in industry? Dhananjay, okay, Dhananjay, Rust programming language, yes, Rust programming language actually is not being used that much in industry right now, and it is not as much popular right now, but for placements, Rust programming is not being asked right now. If we talk about placement perspective, then Rust programming is not much asked, but it is, yes, it is there in the industry, actually, it is there in the industry, and people are using it in startup culture like Bangalore, in different startups Rust is being used, but for placements Rust is not asked usually. Rust is not asked in placements. If you talk about placements perspective, then okay, Dhananjay, I hope so that this is also clear. Anybody, anything else you want to ask? We will move on, we'll continue. All right, okay. So guys, we'll continue from here. So insert at head, okay, insert at head. So insert at head, okay, so insert at head. So let's continue from insert at head. Okay, so three things that I have explained you just now here, that you first create the node, then you copy the address from the head, and then you point the head towards the newly created node, correct? Let's code. Here we are, and we want to first create the node. To create the node, this is the node class, and if you want to create the node, what do? You create the object of that class, node, okay. You create the object of this class, node, and how do you create the object? You say node star n equals to new node. Alright, node star n equals to new node. Now, what do you understand by this? What do you understand by this? Node is a class. Node is a class, and the thing that we are creating is going to be a pointer, because it is going to point and it is going to connect to the another node. Imagine you are creating this linked list, right? You are creating this linked list. If I want to create this node, this will be a pointer which will point towards the next coming node. So hence it will be a pointer of type node class, which we have created up there. Node class is already present up there, and we are just initializing its object. So node star n. N is the name of the object or the node which is going to be getting created. Okay? This is your n. But the problem with the n is that here we need to do memory allocation, DMA, dynamic memory allocation, guys. You remember malloc, calloc, realloc, free. You remember new, delete. If you don't, go ahead and watch our video on dynamic memory allocation in C. We have done creating it, we have created it, we have done that video also. So go ahead and watch that video and come back. But if you don't know, in brief, if I want to explain you what is dynamic memory allocation, then dynamic memory allocation do exist in only C and C++. We cannot do that in Java or Python, because that is done internally by the programming language in Java and Python, and dynamic memory allocation is used to dynamically allocate the memory in the runtime so that the program doesn't fail. I hope so that you have understood. If not, then I have a detailed video on dynamic memory allocation. You can go ahead and watch that also in Coders Arcade YouTube channel, in our channel, right? One more comment came. Sir, are you from Bangalore and do you teach at some university? No, I am not from Bangalore. I don't teach at university. This is my company, Coders Arcade. This is our channel, Coders Arcade. I am not from Bangalore. I teach here in Coders Arcade. Okay, so Coders Arcade is my company. I teach here. Okay, I don't teach in any university. I am not a professor. I hope so that you have understood. A weird question came here, but let's continue. So I was talking about dynamic memory allocation. Dynamic memory allocation. Dynamic memory allocation, allocating the memory in the runtime, so that what happens? Your program doesn't fail in the runtime. As simple as that. Okay. Now, why I want to allocate the memory to this? See, of course, this is a pointer, right? And which type of pointer is this? It is an untyped pointer because, sorry, it is a typed pointer, but it is of type node class. How do you create an object? You write the class name and then you write the object name. Understood? And when you write the object name, what happens? It uses this data type, and this data type is of type node class. And this type is of node class. Alright, node class. So in this case, node is a user defined data type which doesn't have a size. So compiler doesn't know how much memory to be allocated for this n. So what we need to do? Manually allocate the memory. Now this is C++, so we are using new keyword to allocate the memory, just like how we allocate the memory in Java using new keyword. But if you are doing this in C programming, then you would have used malloc, calloc or realloc. But we are doing this in C, so we are using new keyword. I'm sorry if that was weird. I thought I saw you at a university. Yes, we actually go to university and we teach MRN. It's not like that. And ignore the comment which our company did. Comment your problem. Okay, that's not the issue. Okay, that is fine. And I thought you saw in we take the project from universities and we go to universities and then we train there also. But did I train you, MRN? I don't know. If you were in any university, how did you see in a university? In which university are you from? Please message and tell in which university from you are, and if I was there, if I would have talked to you before or not, I don't know. I don't know either, sir. Okay. Alright. Okay. Now we get projects from university and we go to universities also and then we train. But let's continue. Okay. So we created our node, and this is what? This is a constructor call. Node constructor call. This is our constructor call. Okay. So node star n equals to new node. This is our creation of the node. Our first step is done. Creation of the node is done. We have created this node. We have created this node. Now next is gonna be what is the next step? Next step is to connect that node. Okay. Next step is to connect this node with the already existing node. And who has the already existing node's address? Head. So what do you do? Copy the address from the head. And if I want to copy the address, where will I paste it? In the nodes which is ends next. Which means the next code which I will be writing here is going to be node, it will be n of next. N of next is equals to head. So the head's address comes inside n of next and the connection is made. The connection, the newly created node's connection is made with the already existing head node. Second step is done. Third step, we need to move that head pointer from here to here. We need to move the head pointer from here to here. Because head is pointing here. If the head points here, then this will become the first node, but I want my head to point here. So head is equals to n. Head equals to n, correct? So here I will say head equals to n. Understood? I hope so. That this is very much clear, guys. Correct? This is how we create our inserted head, and that's it. That is it. That is it. This scenario, this program will work in all the scenarios when the head is equals to null or when the head is not equals to null. We have made this function according to when head is not equals to null, means when the linked list is present. But if the head is null also, it will also work, because in that case the second line doesn't matter. What I mean to say is, imagine, actually you imagine in your brain, in your head, imagine that if the head is equals to null, that means if the linked list doesn't exist. Okay, alright, let's do one thing, let's create that, let's reproduce that scenario here. Let us say if this is the head pointer, let us say this is the head pointer and head is pointing towards null, and if this head is null, then what will happen? It doesn't point toward anywhere, it is not pointing to any other node. Am I correct? Then where it is pointing? In a void space, in a void or a null space. I hope so that this is very much clear to all of you, right? In that case, how that program will work? First step, what was it? Create the node. So I created a node randomly. Let's imagine that this is not pointing anywhere right now. So I created my node and this is my node. Let us say it has the address 3213, for example. It has this address. Okay. I'll get to that doubt. Just a minute, Dhananjay. I'll get back to your doubt. Okay. I'll finish this. Head is equals to null right now and head is not pointing anywhere. So when I created the node is created. Right now this is null, pointing to no location because it is thing. Now what will happen? I said that first step is done, creation of the node is done. We have created the node. Second is copy the address of head to n of next. If this is n, then this is n of next. N of next is already null. What you are doing is you are copying this null again back here. That doesn't make any change. Understood? So the second line doesn't work for the first insertion. That is it. Okay. And then what you said? Head you point towards end. That head you point towards end. That line will actually make the change and the insertion will happen. So the code works in both the scenarios when the head is not null and when the head is null. I hope so that this is very much clear as well. Now, do we need to always allocate the memory in high level programming language? Can't language handle itself? Yes, languages can handle itself, Dhananjay, but not C or C++. Java and Python can do that. Because Java, for example, let's take Java. Java has its own runtime environment called as JRE, Java Runtime Environment. Now in Java, Java Runtime Environment is present, and in Java, when Java Runtime Environment is present, it is its job, it is his job, JRE's job to allocate the memory, to delete the memory. That is the reason why we don't have concept of pointers in Java or in Python. Are you getting my point, Dhananjay? So in the languages like Java or Python, the memory is allocated by itself. The language manages it itself. Java has JRE, but Python has inner working. So in Python also, the memory is allocated automatically. Dynamic memory allocation happens automatically. So we don't have malloc, calloc, realloc, or we don't have new and delete in Python or Java. See, in Java you have new, but that new and this new is very different. In Java, new keyword will call the JRE to allocate the memory. Automatically the JRE will allocate the memory, okay, Dhananjay. But in Java or Python, you don't have to manually allocate the memory. Automatically it happens. So you don't have the concept of DMA or a dynamic memory allocation there. Understood? And you see, Dhananjay, one more thing, bonus knowledge, one more thing, that because Java has JRE and Python has internal working, we don't have to manually allocate the memory there. That means we don't have to delete it also. That means Java or Python can delete the memory automatically. When any language can delete the memory automatically, that is what you call as garbage collection. So the concept of garbage collection came here. That means Java and Python has their own garbage collection. What is garbage collection? Basically, whatever free memory is present, you free it, or whatever empty memory is present, you clean it. You clean the space which is going to be not used, unused space. You are cleaning that. That is what you call as garbage collection. But garbage collection cannot happen in C or C++ because we are manually allocating the memory here. So it is our job to deallocate the memory also. That is why we have the concept of free or delete in DMA. You see na, malloc, calloc, realloc and free. That last one, free, is the manually deallocation of the memory. So one pro tip guys, if you are using malloc or calloc or realloc, do not forget to use free. If you forget to use free, this question is asked in interviews, guys. Remember that what happens when you don't free up the space? When you don't free up the space, what happens? Memory leak will happen. Memory leak will happen. Okay. That is why we have the concept of free. Whenever you have malloc, calloc, realloc, you have free. Or whenever you use new, you say delete. But this concept doesn't exist in Java or Python. Because you are not allowed to manually allocate or deallocate the memory there. That is why the concept of pointers doesn't exist in Java. That is why the concept of dynamic memory allocation doesn't exist in Java. So you cannot dynamically deallocate or allocate the memory there. That is done by either the internal working of the programming language, like in Python, or in Java you have concept of runtime environment or a virtual environment, you can say. But C and C programming languages are the old languages. 82 and 72 that time, 1982 and 1972 at that time, this technology was not available to us, and that is why everything you used to do manually in either C or C++. That is the reason why you have the concept of malloc, calloc and realloc. Understood? But Java is a very recent, the latest language. It came in 1995. What is the difference between 1972 and 1995? Are you getting my point? It's a huge difference. 1995 is the latest one. Java was developed in 95. But C programming was developed in 72. That is the generation gap here. C came from another generation and Java is totally another. 1995, you can say Gen Z. Java is Gen Z while C is millennial. A good example you can take. So huge generation gap is there. We know this, that after 1995 millennials generation they start now. So Java is Gen Z. So after 1995 it is Gen Z. That means Java is Gen Z while C programming or C++ is millennial. Anyways, I hope so you have understood what I wanted to say, and all of your doubts are already cleared now. Alright, and time is also almost over, guys, so we will end up the live session anyways here. Thank you so much for watching, but I wanted to just tell you about one thing very important, guys. Today I have discussed in our live session today we have discussed about C++ DSA linked list concept, where I have explained you a lot more things about insertion, and we have talked about a lot about this concept of how the insertion it works. I hope so that you have enjoyed it and you have understood it. If you have any doubts, please tell me in the comment section below, and in the chat if you want I can solve the doubt now. No comments right here. So anyways, we will conclude this video, guys. I thank you so much for watching this video, for joining me. I am available on all our social media platforms, so if you are interested, please follow us on all the other, follow Coders Arcade in all the other social media platforms also, like Instagram, Twitter, LinkedIn, everywhere we are present there. We continuously update and we continuously keep on working so that we can bring the latest content to you guys. And thank you so much for watching. Please do not forget to like, share and subscribe to this channel. It helps us a lot to bring our videos up, and that's all for this live session, guys. Now one last thing, in the next live session I will be continuing with this concept where I will tell you about how we can traverse and print the linked list. So one homework I will give you, and homework is that you have to write the traversal function. When is the next live? Next Saturday. Next Saturday is the next live. So the homework is gonna be write the print function in the linked list and do the traversal. Okay, and that's it. So I hope so, guys. That's all for this live session, guys. Thank you so much for watching my live session, guys, and that's all for this video. Take care, guys. I'll see you on the next live session, and bye bye. Take care, guys. I'll see you on the next live session, and